Hello student, good morning. I am Dr.Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss sewage treatment. Sewage treatment. The domestic sewage contains heavy load of BOD, means biological oxygen demand, pathogenic bacteria, color, and annoying smell. If such raw wastewater is discharged into natural water bodies like rivers, lakes, and sea, they get contaminated, causing first depletion of dissolved oxygen, means destruction of fish and other aquatic life. Second, color and smell affecting the quality of water. Third, pathogenic bacteria causing waterborne disease. The domestic sewage therefore needs proper treatment before it is either discharged into natural water bodies or recycled. The treatment aims at the removal of oxygen demanding organic compounds, suspended and floating matter, and other matters such as ammonium salts, phosphates, pathogenic bacteria, etc. The sewage treatment is carried out in three steps or stages. First, primary treatment. Second, secondary treatment. Third, tertiary treatment. Three treatments are done to get the good quality of water from sewage water. Then I will discuss one by one. First, primary treatment. Primary treatment involves a screening. Second, silt and grit removal. Third, oil and gas removal. Fourth, sedimentation. These four steps are done under primary treatment. First, screening. Second, silt and grit removal. Third, oil and gas removal. Fourth, sedimentation. Now I will tell brief about all these 4 points. First, screening. How we will do a screening? How a screening is done? It is a physical process. A screening is a physical process which removes large suspended or floating matter in the sewage. This is accomplished by using bar screens and mesh screen which retain the floating and suspended coarse particles when sewage water is passed through it. Second, now silt and grit removal. How we will remove silt and grit? Grit means sand, broken glass, etc. Then silt and grit is removed. These are removed by passing sewage through grit chambers in which the velocity of flow of sewage is reduced. being heavier, silt and grit particles settle down at the bottom. Now third, removal of oil, grease, etc. How it can be removed? Oil and grease. Oil and grease are removed in skimming tanks. They are converted into a soapy mixture by blowing compressed air through sewage water in a skimming tank and lifted to the water surface in the form of foam. Okay, the floating substances are skimmed off. This I have told about removal of oil and grease. Now fourth point, that is the coagulation and sedimentation. How it is done? Coagulation and sedimentation. Sedimentation, how it is done, that now I am telling you. That is the fourth point, sedimentation, fourth step. Then here sedimentation process, now I am telling you. It removes finer suspended impurities. This is brought about by plain sedimentation in a continuous flow type sedimentation tank, or by sedimentation with coagulation. The coagulants used are alum, potash alum, second ferrous sulfate, etc., which help in the easy settlement of finely suspended particles. This I have discussed about the primary treatment. In primary treatment, all these four steps are done. Now secondary treatment. What is actually secondary treatment? Then this is also called biological treatment. Biological treatment, or we can tell aerobic biochemical oxidation. Aerobic biochemical oxidation, also called aeration. Then now I am telling about secondary treatment, also called biological treatment or aerobic biochemical oxidation or aeration. The sewage water after sedimentation. What we have done, primary treatment. After the primary treatment, last step was sedimentation. Now after sedimentation process, secondary treatment is done, means biological treatment. The sewage water after sedimentation is subjected to aerobic oxidation, during which the organic matter is converted into carbon dioxide. The nitrogen is converted into ammonia, and finally ammonia is converted into nitrite and nitrates. Bases, actually in this suspended particles, or you can tell sewage water, in the sewage water bases may also present. Then bases present in the sewage water form salts like ammonium nitrite, ammonium nitrate, calcium nitrate, etc. Secondary treatment or biological treatment is generally accomplished by activated sludge process method. Activated sludge method. That is the main step is this only under secondary treatment. What is actually this activated sludge process? What happens in secondary treatment? This is the main step. Now I am talking about activated sludge process. Activated sludge process involves extensive aeration of the sewage water and the process of aerobic oxidation being enhanced by addition of a part of sludge from previous oxidation process into sewage water. The added sludge from the previous oxidation batch is known as activated sludge. Again, I am telling you, the added sludge from the previous oxidation is known as activated sludge, since it contains large number of aerobic bacteria and other microorganisms. The sedimented sewage water is mixed with proper quantity of activated sludge, and the mixture is sent to a aeration tank, in which mixture is aerated and agitated for several hours. Means it is mixed properly, agitated, that is mixture is aerated and agitated for several hours. During this process, organic matter are oxidized because oxygens are present there. More oxygen, or we can tell more air is present. During this process, organic matters are oxidized. After the process is complete, the effective effective effluent, we can tell, after the process is complete, means mixing is over, the effluent is sent to a sedimentation tank where sludge is deposited and water free from organic matter is drawn off. A part of the settled sludge is sent back for seeding fresh batch of sewage. Here important point is that after the process, means mixing process is over or completed, the effluent is sent to a sedimentation tank where sludge is deposited and water free from organic matter is drawn off. And to repeat the process, a part of the settled sludge is sent back for seeding fresh batch of sewage. Now we talk of the effluent, that is water we got. Now this all particles settle down during the sedimentation process. Then we got the water. That water actually is called effluent. Then this effluent actually is sent to a sedimentation tank where sludge is deposited and water free from organic matter is drawn off. Now I am talking about this water. Means organic matter is settled down. Now water is above. Then I am talking about that water. The effluent from secondary treatment has much lower organic load. Now this water what we got now is somewhat you can say purified. The effluent from secondary treatment has much lower organic load. This water after chlorination to kill the pathogenic bacteria, it is discharged into lakes, streams, rivers and sea. Means major treatment has been done, and after this treatment we can send it, we can discharge into lakes, streams, rivers and sea. Now third means tertiary treatment. Tertiary treatment. What we have to do in this treatment? Then here the aim of the tertiary treatment is further purification of wastewater. Whatever we got water, we have to do treatment for this water, further purification. The aim of tertiary treatment is further purification of water, wastewater, as well as its recycling. Again, whole process we have to repeat, recycling. Then here under the tertiary treatment, under the tertiary treatments 5 steps are there. First, actually mainly here is the chemical treatment. Then first is removal of phosphate from this effluent water or wastewater what we got under secondary treatment. Under secondary treatment we got the water. Then now that water that is called effluent is further we have to treat it. Further we have to purify. Then that is done under the tertiary treatment. Then in that first step is removal of phosphate. Actually 5 steps are there. Then first removal of phosphate, second coagulation and sedimentation, third step is filtration, fourth step is degasification, and last step is disinfection. Then I will brief it how this can be done. Removal of phosphate first. How we will remove the phosphate? Then phosphates are removed by adding calcium hydroxide. A flocculent precipitates of calcium phosphate is formed at pH 10 to 11. Means after mixing calcium hydroxide we will get calcium phosphate that can be removed. Okay, and ammonium salts are converted into ammonia gas. In this effluent water, ammonium salts generally it will be present. Then ammonium salts are converted into ammonia. Okay, now after that second step is coagulation and sedimentation. Coagulation means just simply you can understand just like a precipitation, it will settle down. Then how you can say it will settle down, that I am telling here. That actually is done under the coagulation and sedimentation. Then here what will happen? The suspended fine particles, effluent means wastewater has suspended fine particles. Then the suspended fine particles are removed by sedimentation in the presence of coagulants like potash alum, ferrous sulfate, etc. The flocculate precipitate of aluminum hydroxide and ferrous hydroxide formed by coagulants entrap the fine particles and help them to settle down. Actually, potassium and ferrous sulfate, these are actually coagulant. Then this potassium provides, it gives aluminum hydroxide. It produces aluminum hydroxide, and ferrous sulfate produces ferrous hydroxide. Potassium produces aluminum hydroxide, and ferrous sulfate produces ferrous hydroxide with water. Okay, potassium and ferrous sulfate we have added in that effluent water. Then this potassium will produce aluminum hydroxide and ferrous sulfate will produce ferrous hydroxide. Then these aluminum hydroxide and ferrous hydroxide formed by coagulants entrap fine particles and help them to settle down. The highly charged ion of coagulants, actually aluminum has, for example, 3 positive charges there, Al 3 plus 3 charge, ferrous also 2 plus. Then here the highly charged ions of coagulants also neutralize the charges on colloidal particles, and colloidal particles means here suspended particles, and make them to coagulate and settle down. Coagulation will take place, means it will precipitate, it will settle down, and that can be removed. Now third step, that is the filtration. For filtration, the water is passed, means after removing this precipitate, whatever water we got, I am talking about that water, that is called that is a filtrate. Then now we have to do filtration. Further we have to, this water we have to filter. Then filtration. For filtration, the water is passed through a conventional sand filter beds, means through the sand we have to pass. Sand will be there, that is called sand beds. Okay, sand filter beds to remove the last traces of suspended particles. Actually, suspended particles already settled down. Despite that, if some particles are remaining, to remove that particles, it is passed through a conventional sand filter beds to remove the last traces of suspended matter. Now next point, that is the degasification. Actually, in that water many gases may be present. Then we have to remove that gases. As for example, ammonia gas may be present, carbon dioxide may be present, hydrogen sulfide gas may be present. Bad smell will be due to these gases. In any wastewater, bad smell, annoying smell will be due to these gases: ammonia gas, carbon dioxide gas, sulfur dioxide gas, hydrogen sulfide, etc. Then we have to remove this gas. Then for that purpose, degasification is done. A stripping of ammonia and other gases is done in a degasifier. The degasifier consists of a large tower fitted with a number of perforated plates. The hot water trickles through these plates. Hot water. Then hot water also helps to remove the gas. High temperature helps to remove the gas. Okay, that's why hot water is passed through the plates. The hot water trickles through these plates. Large surface area and higher temperature promote a stripping of dissolved gases like ammonia gas, carbon dioxide gas, hydrogen sulfide, etc. Now, last step, that is under the tertiary treatment, that is the disinfection. The pathogenic bacteria are destroyed by disinfection. Among many disinfectants are there. In that chlorine is cheap and effective. Then this chlorine gas is passed through now this water, because water after this gasification, whatever water we got, means after filtration through sand water, whatever water we got, from that water gas we have removed. Now that water, after removal of gases, now in that water, last step, that is the disinfection, is done. How? Then here chlorine gas will be passed. Correct? Then pathogenic bacteria are destroyed. Okay. Then chlorine actually reacts with water, Cl2 plus H2O. It gives HOCl, unionized HOCl. Okay. And also it gives HCl gas. And that time pH will be around 6.5, means roughly normal. Okay. Not normal water has 7. pH means negative logarithm of hydrogen ion concentration. That is called pH of a solution. Then here this chlorine gas, when it is dissolved in water, it forms HOCl, which is unionized, and it also forms HCl, H plus Cl minus. Okay. Now unionized HOCl attacks the bacteria and it kills them. This HOCl, hydrogen oxychloride, unionized HOCl attacks the bacteria and kills them. Actually chlorine gas, that's why chlorine gas is used to kill the bacteria directly. But here when we are passing chlorine gas to the water, it forms two gases. Okay. First it will form HOCl, hydrogen oxychloride, plus HCl. Okay, because it is dissolved in water. Okay, then it has acidic character. Then HOCl, what actually it does, main role is this HOCl, hydrogen oxychloride. Unionized HOCl attacks the, you can say, bacteria and kills them. The final composition of tertiary treated water, wastewater, now it became normal. Now that water became normal. Treated water has high clarity, free from odor. Now no odor, no bad smell, all bad smell went. Now water became high clarity, you can tell. Treated water has a high clarity, free from odor, low BOD. Low BOD means that is a biological oxygen demand, that is less than 1 ppm. It is very good, just like a normal water. BOD, now it became less than 1 ppm. And ammonium ion also reduced. Ammonium ion present in water, now it became like a normal. It reduced, less than 1 ppm. It is under the range. Phosphate also reduced and it also became under 1 ppm, just like ordinary water. Therefore, it is nearly equivalent to drinking water and can be recycled. Okay, then this I have discussed about sewage water or sewage treatment. From the sewage water, how we will get drinking water, I have discussed in details. Thank you.